Sorry about that. It was.
Oh, no, no, no problem, no problem. Yeah, no, no, no problem. Yeah, so then we go with tan of theta here. This is a very simple one, right? Tan of theta is adjacent, or sorry, opposite over adjacent. Because we're talking about the angle in the standard position, we have to take it with direction and magnitude. So therefore, it'll be 5 into tan of theta is what? Opposite over adjacent plus 1, which is equal to the 5 and the 5 will cancel, so it'll be minus 12 plus 1, which is equal to minus 11. Simple as that, right? So yeah, we get the idea, right? So we basically get the idea. That's calculator skills. Here you're going to use, um, you're going to use the special angle triangle, right? Here we're going to solve for the equation. We're going to solve for theta. So here we have to do this one. Let me do this one here, right? The sine of 45 and the cos of 45 will be 1 over root 2 over 1 over root 2, which will be 1, minus 5. Cosec is 1 over sine, so it'll be 5 over sine of 90 degrees, plus 4 times the tan squared of 30. Tan of 30 is 1 over root 2. So it'll be 1 over root 3, 1 over root 3 squared, right? So we do this here. There's a 30, 60, 90, 1, 2 root 3. So tan will be 1 over root 3 squared. And if we solve, so this will be 1 minus, see sine. Now look at this here, Sumesh. There's a trick here. These are two graphs I want you to remember. And you've started doing it, but I'm just giving you some insight here. This is the sine function, and this is the cos function. See, cos at 0 degrees, see where it starts off at. It starts off at 1. For sine at 0 degrees, it starts off at 0, and then at 90, at 90 degrees, it goes to 1. At 90 degrees, it goes to 1, right? And here, I think at 90 it is 0 degrees. So now they tell you not to use a calculator. The reason they're telling you not to use a calculator because they want you to know the basic function of the of sine and cos. So if you do that there, you get 1. Right? So they told you not to use it, but you can go use it, right? So it'll be sine of 90 is 1 plus 4 times 1 over 3. So it'll be 3. And then if you add all of this here, you'll get an answer. Right? So the cos function assumes the shape here. It goes like that there. Starts off at 1, then it goes to 0. And then yeah, the sine function starts off at 0 and go to 1. So it starts off from 0 and then it goes to 1 at 90 degrees. Here it goes to 0 at 90 degrees. Okay, so on the x-axis, you don't have x now, you have theta and y. Y and theta. Right, so your x is your theta values. Now, this is going to be a very interesting discussion when we get to term 3 trigonometric functions. All of these problems here, exactly like how we had linear, quadratic, and exponential. Now, when we have these equations, where do you think these come from? Trigonometric functions now, right? That's the difference, trigonometric functions. Right, very interesting stuff you're going to see, right? So here, it'll be sine of 2 theta minus 25 degrees is equal to half. Take the arcsine on both sides. It'll be 2 theta minus 25 degrees is equal to 30 degrees. 2 theta is equal to 5 degrees. Theta is equal to 5 over 2 degrees. Right, and we solve that there. So that's simple stuff, right? I'm going to go to much more complicated stuff now. Let me just browse through this. Um, yeah. Yeah, there's the one here. There's a problem here now. You see, before when we did the other problems, we were given the statement here and we were given a diagram. Now they'll give us a statement and they'll want us to draw the diagram. So how are we going to do that? Watch it. Yeah, it's stating, right? If we redo this one here now, redo this question. If you look at sine 45 and cos of 45, looking at the special angle triangle, you get 1 over root 2 and 1 over root 2. That part we know. Here we get minus 5 over sine of 90. See, cosec of 90 is 1 over sine of 90. So what I said you must remember here now is the two functions, sine and cos. The cos function does this here, and the sine function does this here. The basic shape of it. So at 0, this will be 90. This point here will be 270 degrees. No, sorry. 90, 180, 270, and 360. Okay, me make it bigger so you can see it. So it does this here, right? Looks like this here. 0, 90, 180, 270, 360. Right, Sumesh, check here. Watch how brilliant this is. So this is what it's going to do. The function will move within the range, the set of y values, the range of 1 and -1. So at 0, it outputs 1. So if I have, so the name of this function here is y is equal to cos of theta, right? At 0, if I input theta to be 0, I'll get y value to be 1. If I input theta, because remember on this x-axis here, we have theta, right? If I input theta to be 90, I'll get a y value to be 0. Input theta to be 180, I'll get a y value to be -1, right here. Input it to be 270, I get 0. Input it to be 360, I'll get 1. Right? That's the basic shape of it. Now, you must take this down here. Because what I was saying that when we talk about trigonometric expressions, this is a trigonometric expression. In term 3 now, it'll become what? Trigonometric functions. If we're talking about trigonometric equations, in term 3, what it'll become now? Trigonometric functions. Exactly as we discussed, linear, quadratic, and exponential equations and expressions, it became what? Functions. Powerful stuff here. Right? The way you remember this now is the range of the cos function is 1 and -1. Right? It oscillates between these 2 points, between these 2 extremes, right? So yeah, that's the standard function. The parent function for cos is this here, right? And then you just remember 0, 9, 18, 27. So 9, 18, 27, 360. And then you just draw your points. It'll just oscillate. It'll be 1, 0, -1, 0, 1. Right? Do you have this down, Sumesh?
No, 1 second.
Okay, cool. No stress. Take it down. No rush.
Must have to check on the purple one also.
Yes, please. Yes, please, Sumesh. Do you have that, Sumesh?
Yeah.
Okay, perfect. Now let's go over this here now. See, sine function, same story. 0, 90, 180, 270, 360. These are like critical points, points that you must remember. What shape does it assume? It assumes the shape here like one wave, right? You can see this wave here. What it does is 0, 90, 180, 270, and 360. It'll go 0, 1, 0, -1, and then 0. Now, why I did this here now is because see when you given numbers like this, say sine of 90, right? Or sine of 180, or sine of 270, or sine of 360. These are values that you're supposed to commit to memory. But we can't remember these things, so that's why we learn these diagrams. Because if all of these things are going to come from functions, then we can use functions to solve them, right? And so what we can say is sine of 90 is what? What does it output when you put sine of 90 here? What y value does it output? 1. So that there will be 1. So this here and this here will cancel. It'll become 1 minus 5 over 1 plus 4 over 3. So put that there, solve it however you want to solve it, and then you'll get an answer. Right. Now you see what's so significant about this, and I just want to give you some insight here. Let's say if I have like this, something like this, and tell you solve for theta. Cos of theta is equal to 2. Right? You can do anything. You can put theta is equal to cos inverse of 2, put it into your calculator, right? Because we're trying to solve for theta, shift cos of 2 is equal to what? Error. And then you ask yourself, okay, why is that the case? Think about it. There is no imaginable theta value that I can input in here such that I'll output a y value that is 2, because the cos function oscillates between 1 and minus 1. Do you see that, Sumesh? That's the extreme, the upper extreme. It cannot go beyond that. Do you understand? That's why this is impossible, right? So they can give you this question here, like this here, to solve for theta. Then you must say that of theta, cos of theta is the same as y, lies between minus 1 and 1. Can you see that? Logic. See, cos of theta is the same as y. The y values that it will output will always be between 1 and minus 1 and 1. So therefore, this is impossible. Can you see that, Sumesh? So this is like some foresight as to what to expect next term, and they could trick you and put a question like this now for you. Nothing stops you.
Yeah.
Okay, wait. I think you just take that down. Where's this? Great. Let me just rewrite it. So it'll be cos of theta will be between minus 1 and 1, or and where it comes from, where the logic comes from, is at the y value. You don't write this y one, yeah. This is just for you to see from a perspective of functions. I can do the exact same thing. I can say sine of theta is equal to, let's say, minus 5. Put this in the calculator. You can't solve for theta. You'll say there's no solution, and you'll say that sine of theta lies between minus 1 and 1. So there's no imaginable theta value that I can input here that will output a y value that is negative 5. It has to oscillate between the range. The range is a y values will be between 1 and minus 1. Okay, so yeah, let's keep it like that. Okay, tell me when you're ready.
Yeah, I'm ready.
Okay, perfect. So you got the sine and the cos one now.
Yeah.
Perfect. Right, let's move on to something. Okay, yeah, we did that. Okay, yes. Sumesh, so look at this one here now. Previously, right, they gave us a statement here, right, and then they gave us a diagram that we needed to do. So just look at this here. Take a picture of this or screenshot or whatever. Look at this, right? Look at this, and then look at this question here. This one here. Yeah, same thing. They gave us the same thing here. See, now they told it something cosec theta is equal to something else. Yeah. So they gave you some information and then they gave you a diagram for it. Now what we're going to do is we're going to draw the diagram and we're going to solve. So how are we going to do that? Straightforward. So if we do this, we'll say, okay, cosec of theta is equal to minus 2 over root 3, right? But cosec of theta is what? 1 over sine of theta is equal to minus 2 over root 3. If I make sine of theta the subject of the formula, I'll get root 3 over minus 2. So it's the same as saying swap the numerator and the denominator here. Swap the numerator and swap the denominator. Now, here's the powerful rule that we learned from fractions last year. Remember when we had the 30-day program? There's it here. This minus sign is floating, and you'll see why is it so significant. Remember we said sine, we're talking about the Cartesian plane now, right? Mind you, we're talking about the Cartesian plane here. We said that sine is, shade your ear, is equal to y over r. R is the radius, and the radius can't be negative because you're talking about theorem of Pythagoras, it has to be positive. So the negative cannot go to the denominator, it has to strictly be to the numerator. And so if I sketch a diagram now, if I sketch a diagram using this, you'll see exactly what I'm saying. So we want to know, they're saying that root 3 cosec of theta plus 2 is equal to 0. We simplified down, we re-expressed it, we got sine of theta is equal to root 3 over 2, right? But then they're also saying that this theta value must lie between 90 and 270, between quadrant 2 and quadrant 3. And so what you got to do is, you got to say, look at it like this here. They're saying that they're giving you this relationship, yes, sine of theta is equal to minus root 3 over 2. And they're saying, but it must lie between either in quadrant 2 or quadrant 3. You need to ask yourself, isn't in quadrant 2, if we look at the cast diagram, um, in quadrant 2, sine is positive, but yet they're saying sine is negative. So where does it have to be? It has to be where? In quadrant 3. Right, so in quadrant 3, sine is negative and it satisfies this restriction. So we satisfied both the restrictions and both the restrictions, both the conditions. So this is why I'll draw my diagram here. The theta now will be where? Here, quadrant 3 like that there. Root 3 will go where? It will go on the y-axis, so negative 3, and r will be 2. Can you see why r has to be positive now? Why the negative had to move from where it is? So we take this out here. It will be minus root 3 and 2 there. Right? And then if we solve for y now, if we solve for y, what will we get? We'll have y squared is equal to the square root of r squared minus x, x squared. What am I saying? X squared is equal to the square root. So it'll be x squared is equal to r squared minus y squared. R is what? 2 squared. Minus y is what? Square root of 3 squared, which will give me 4 minus 3, which is 1. So therefore, x is equal to plus or minus 1, but x has to be minus 1 because it lies on the negative x-axis. So it'll be minus 1 there. Right, and then what's your reasoning here? You have to write the reasoning theorem of Pythagoras. Okay, so let me go over this one more time. I want to go over this one more time. In this question, we are not required to we don't have the diagram, right? We don't have the sketch, so we have to draw it. Right? We have to draw. That's what they say, use a sketch to determine the value. How do we do that? Re-express this as sine theta equals to cos theta equals to or tan theta equals to. That's part one. Once you have that part, then look at the next condition restriction. It says it has to be between quadrant 2 and quadrant 3, right? But we know in quadrant 2 sine is positive. Why? Because sine is y over r, and in quadrant 2 y is positive, and r is always positive. So positive over positive is positive. But they're saying according to this relationship, sine is negative. So between those two quadrants, it can't be quadrant 2, it has to be quadrant 3. So if I put my sketch into quadrant 3, and I put the y and the r values, I get root 3, minus root 3 and 2. If I solve for x now, using the r squared is equal to y squared plus x squared. If I solve for x now, I get x to be minus 1. Now we can use all this information here. Once you got x, y, and r, you can solve this question. What is cos of theta? This is the angle in the standard position, so we have to take the values with the magnitude and the direction. Cos is what? Adjacent over hypotenuse. Minus 1 over 2. Sine of theta is what? We solved it here. Minus 3 over 2. Cos of theta is what? We solved it on top there. And tan of theta is equal to what? Opposite over adjacent. So it'll be root 3 over minus 1. So minus root 3 over minus 1. And the minus and minus cancels. That's why tan is positive there. If we simplify this, this will be equal to minus root 3 over 2 multiplied by minus root 3 multiplied by the reciprocal of the bottom will be minus 2 multiplied by minus 2 over 1. The 2 and the 2 will cancel there. And so now we're left with minus times a minus times a minus is a minus. Root 3 times root 3 is 3. So we're left with minus 3. Can you see that, Sumesh? So we're going from this piece of information to this, to theorem of Pythagoras, and to what we've always been doing. We've done this here repeatedly. The only thing you have to do different now is draw the diagram. Now, please, when you draw this diagram, label your axes, call it X, call this Y, put that 90-degree symbol in there. The angle that you draw now will be the angle in the standard position. Right, so that should be from the positive x-axis to the terminal arm. Okay. Do you understand, Sumesh?
Yeah, I understand.
Okay, perfect. This one here is a straightforward question, right? This is we're using calculator. So let me do another question of the similar nature. Oh, geez, I don't even have another one. let's just do this question here. I'll get another one for you now. I'll get another one. Yeah, okay. In the diagram below, point P as the coordinates x and y is a point in the fourth quadrant. BOP has the angle in the standard position of theta, right? So we simplify this um, equation. What will we get? We'll have cos of theta is equal to 15 over 17. Okay, very simple stuff. So we got cos of theta is equal to 15 over 17. But we know according to the relationship, shade your rear, cos x raised, tan your exterior, it's x over y. So that 15 will go to the x-axis and this 17 will go to the r, the radius. Right? If you have to solve for this y value now, we'll have y squared is equal to r squared minus x squared by reason of theorem of Pythagoras. And then y is equal to plus or minus the square root of what's r? 17 squared. What's x? 15 squared. And if we solve for this now, we get 15 should be the square root of 17 squared minus 15 squared, which is 8. Right, plus or minus 8. It has to be minus 8 because it lies in the negative y axis. Right. Determine the length of OP. Determine the length of OP. OP is equal to, so OP is from there to there is 17 units. Right, 17 units. It can be read straight from here, right? Straight from there. Tan of theta is equal to opposite over adjacent. So tan of theta is equal to opposite minus 8 over adjacent, which is 15. Remember, because theta is the angle in the standard position, we have to take these values with both the magnitude and the direction. Right. This is a very nice question. Prove that cos squared theta is equal to, cos squared theta plus sine squared theta is equal to 1. Now, when we talk about prove that, this is where we're going to go to trigonometric identities. So if you look at my term 1 overview, I said that there's 4 types of mathematical statements. There's expressions, equations, inequalities, and identities. So this is what we call an identity. Okay. The way we do this is very simple. You break the equation up into 2 parts, the left-hand side and the right-hand side, right? So the left-hand side and the right-hand side. You solve for the left-hand side and prove that the left-hand side is equal to the right-hand side, right? So let's do this. Let's ignore this part. Let's just work with the left-hand side. So cos square of theta plus sine square of theta is what? What is cos theta? Cos of theta is what? X over r. Remember, we're talking about sine, cos, and tan in the Cartesian plane. That's the reason why we use x and r. Right? We don't use opposite and adjacent and all of that, the Soka Toa rule, because we're talking within the topics of x and y. So this will be x over r squared plus, what is sine squared theta? Y over r squared. Remember, Sumesh, we are using logic. We are not changing anything. Right. If I do this here now, I'll get x squared over r squared plus y squared over r squared. If I combine this, x squared plus y squared over r squared. But what is x squared plus y squared? X squared plus y squared, isn't it? So if I see x squared plus y squared, what can I put in? R squared. So r squared over r squared is what? 1. Right? That's from theorem of Pythagoras. Right, 2 marks there. It's equal to 1, but what is 1? What is 1? 1 is the same as the right-hand side. So this left-hand side here, dot dot, is equal to the right-hand side. When you can prove left-hand side equal to right-hand side, then we've proved an identity. Right? We proved an identity. But it's just a way, it's just a technique or way of doing it. Prove the left-hand side, show that the left-hand side is in fact 1, which is in fact the right-hand side. So left-hand side equal to right-hand side. Understood, Sumesh? You want me to go over that again?
Yeah.
Okay, cool. Let's do this again, right? Yeah. When we did, remember we did this, the topic like this here. Remember we did this one here. X squared minus y squared is equal to x plus y, x minus y. This is what we call an identity. But it's just saying, okay, an identity is just like a generalized rule. If you have a perfect square minus a perfect square, this is the form it takes. Here, what this thing is saying is, if you have cos squared of some angle plus sine squared of that same angle, it can be simplified down to 1. Understood? If I have cos squared of some angle plus sine squared of some angle, it can be simplified down to 1. I can put any imaginable theta value here because they didn't tell me any restrictions. They're just saying this remains true for any theta value. It remains true for any theta value. Sine square of 1000 plus cos square of 1000 is equal to what? 1. That's what an identity is. It's like a generalized rule. When you're trying to prove an identity, so this is the only identity. Okay, I'll show you the other one. I'll show you there's only two that you need to remember at grade 10. Please take these things down. So cos squared theta plus sine squared theta is 1. That's the first identity. And the second one I'll show you just now. The way you prove both of it is very similar. It's exactly like this here. We prove it using this y over r and x over r. If we do that, then we get the following. Cos squared of theta is equal to x over r squared plus what is sine squared of theta? Y over r squared. Yes? And then if we do that there, you'll get x squared over r squared plus y squared over r squared, which is equal to x squared plus y squared over r squared. If I want to simplify this down further, because of the theorem of Pythagoras, you in the Cartesian plane, we don't say a plus b squared is equal to h squared. Now we say r squared is equal to x squared plus y squared because we're talking about it in terms of the Cartesian plane, x-axis, y-axis, radius. And so it'll be r squared over r squared, which is equal to 1. But to conclude this, we just say left hand side equal to right hand side. So at the end, we say equal to right hand side because we said left hand side is equal to, we said it like this. We said left hand side is equal to this, which 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 is equal to that. That's the conclusion statement. So therefore, we said left hand side is the same as right hand side. So we proved the identity. Okay. The second one you could be given, I doubt though they'll ever give you all this, is tan theta is equal to sine theta over cos theta. So how do you do this here now? Simple. Left hand side equal to right hand side. What is left hand side? Left hand side is what? What is tan theta? Y over x. Can you do anything with this? No, you can't. Right? So let's work with the right hand side. Right, Sumit? These are two techniques, right? You can work with the left hand side, get something, work with the right hand side, get something, then say left hand side equal to right hand side. So there's another way of doing it, or the only two ways you could do it. What is sine of theta? Sine of theta is y over r. What is cos of theta? X over r. Y over r, if you're dividing by x over r, is the same as multiplying by r over x. R and r cancel, so what are we left with? What are we left with? Y over x, which is the same as what? Left-hand side. There's it here. Can you see that? Left-hand side equal to right-hand side. Can you see that, Sumit? That's how we get to tan theta is equal to sine theta over cos theta. And so what we're saying is, put in any imaginable value of theta. I do this here. Watch here. If I say sine of 600 over cos of 600, right? Sine of 600 over cos of 600 will give me something. What does it give me? Root 3. And if I say tan of 600, what does it give me? It should give me root 3. That's how that identity works. Exactly like how we did identities for special binomials in factorization. There's the same idea here. Right? This is why terminology is so important, and I bring those things in so early because see now it's starting to link now to everything. Right? But anyways, the technique is simple. You say work with the left-hand side and prove it to be the right-hand side, or work with the right-hand side and prove it to be with equal to the left-hand side. See, here we work to the right-hand side, proved it to be equal to the left-hand side, or you can work with the left-hand side and prove it to be equal to the right-hand side. Understood, Sumesh?
Yeah.
Right, 100%. You got these down, or I must give you some time?
Just give me some time.
Okay, cool. No stress. No rush. No rush. Take it down neatly.